In this video, we'll guide you through the steps to easily integrate your CyberArk Privileged Access Manager with Securosys CloudHSM or our on-premises Primus HSM cluster. This integration gives you the advantage of secure key generation and storage on the HSM, which not only offers additional security levels, but also helps meet regulatory requirements. CyberArk's self-hosted Privileged Access Manager is a comprehensive solution designed to manage the entire lifecycle of privileged accounts and SSH keys within your organization. With CyberArk PAM, you can secure, provision, manage, control, and monitor all activities associated with various types of privileged identities, such as administrator on Windows Server and others. Securosys Primus HSMs are high-performance, on-premises hardware security modules designed to safeguard cryptographic keys and sensitive data, ensuring robust encryption and compliance with strict security standards. With seamless integration, scalability, and advanced protection against cyber threats, they build the foundation of securing enterprise environments. Securosys CloudHSM is our managed hardware security module as a service. It provides secure, cloud-based HSMs for generating and managing encryption keys used by your applications. Built on proprietary hardware and software, CloudHSM offers end-to-end control without intermediaries. In today's world, where hacks and data leaks are becoming more and more common, it's crucial to keep your key data encrypted. If your CyberArk server keys were hacked or leaked, the loss of privileged access credentials could be detrimental to the company's operations. The importance lies in how the data is encrypted and where the keys are stored. By integrating your CyberArk PAM solution with Securosys CloudHSM or the on-premises Primus HSM, you can rest assured you will have the highest grade secure hardware storage of cryptographic objects and true RNG key generation. While we'll demonstrate the integration using CloudHSM, the process is the same for integrating with our on-premises Primus HSMs. Whether you opt for our managed cloud solution or prefer an on-premises deployment, you'll enjoy the same level of security and ease of integration. As for prerequisites, for a start, you will require the CyberArk Privileged Access Manager completely installed and set up. It can be already in use or as a first-time setup. Then you will have to have your on-premises Primus HSM deployed and configured, or your CloudHSM partition onboarded, both with PKCS 11 API license. You'll need your partition credentials as well as PKCS 11 API credentials to integrate with CyberArk Vault. For CloudHSM, these credentials are provided to you during onboarding. For on-premises setups, please ask your HSM administrator to give you the necessary information. And for the latest, make sure to download the Primus PKCS 11 provider and save it on your CyberArk server host machine. Let's move on to installing the Primus PKCS 11 provider. This is crucial for the API connection between the CyberArk Vault server and your Primus HSM or CloudHSM partition. We'll log in to the host machine where the CyberArk Privileged Access Manager Vault server is installed. After successfully downloading the Primus PKCS 11 provider, you'll find a zip file. Extract those files to a folder and start the Windows installer. The installer will walk you through the quick steps of the installation. Once installed, it'll confirm the successful installation of the PKCS 11 API, and we can move on to configuring it. Next, let's open the folder where we installed the Primus PKCS 11 provider software. We'll navigate to Program Files, Securosys, Primus P11. To set up the PKCS 11 API connection to the HSM, we first need to configure the primus.cfg configuration file. This file is a template configuration provided by Securosys. Open it with your favorite text editor. The Primus PKCS 11 configuration has three main sections: global configuration, HSM configuration, and login configuration. We'll focus on configuring the HSM connectivity. Here you'll see HSM1 as the first listed HSM. In this section, you define the host name, API connectivity port, and the slots or partitions on the HSM that you want to connect to. For more details on these parameters, please refer to our PKCS 11 online documentation. In our demonstration, we'll use the template for a single partition deployed in a high availability Cloud HSM cluster with 2 geo-redundant HSM locations, each with its own IP address. The Cloud HSM credentials are sent to you during partition onboarding. Other connectivity details can be found on our online documentation. For more, please see the link in the description. Now let's connect to our Cloud HSM partition. Within the slot section, set up the client ID as desired. It'll be used as an identifier of the partition in the logs. The first Cloud HSM we're connecting to is ch01-api.cloudhsm.com. The PKCS 11 API port is 2310. We'll also define our partition ID and insert the name of our Cloud HSM partition we're connecting to. In our case, this is Securosys MSI. As we're connecting to the Cloud HSM service, we'll also need to specify the proxy user. In our case, this is again Securosys MSI. Under HSM2, we'll configure the connection to our second Cloud HSM device in the cluster, ch02-api.cloudhsm.com. Then let's copy over the partition parameters from the previous section. After fully configuring the file, don't forget to save it. If you have on-premises Primus HSM devices, the process to configure the PKCS 11 API connection is the same, though a proxy user is normally not required. We recommend talking to your HSM administrator regarding your connection parameters and the credentials. Now that we've configured the Cloud HSM connectivity, we need to establish a secure connection between the host computer running the private ARC server and the HSM. This can be done using the ppin utility. Open the Windows command prompt as an administrator and navigate to the Primus PKCS 11 provider folder where the ppin utility is located. Use the command ppin-l to list the accessible partitions. We see that the permanent secret is missing for both HSMs in the cluster. Additionally, we also see missing the proxy secret. We'll first use the ppin-p-e command and our proxy username Securosys MSI to add the Cloud HSM proxy password. We'll insert the proxy password that was provided to us during the onboarding process. We see that the proxy password has been successfully configured. We can now use the ppin-a-e command with our Cloud HSM partition name to fetch the permanent secret. We're prompted to enter the setup password and the PKCS 11 pin, which again are provided during the onboarding process. We can see that the permanent secret has been configured and can move on to configuring the private ARC server to connect to and use the HSM to generate and store keys. Having successfully configured the Primus PKCS 11 provider, it's time to configure the CyberArk Vault server to connect to the HSM using the provider library. We'll navigate to the private ARC server configuration file dbparn.ini and open it with your preferred text editor. Here you'll see the location of the server private key, which will later change to reflect it being on the HSM, the recovery private key, and several other parameters. We'll need to add additional parameters to enable and configure the connection between the private ARC server and the HSM. Add the parameter allow non-standard firewall addresses for each HSM you're connecting to and specify the port for the connection. To find the connection details for Cloud HSM, please refer to the online documentation. Copy the URL, set yes to allow, and specify the PKCS 11 API port, and ensure the traffic is set to outbound TCP only. Let's add the connection to the other HSM in the cluster as well. Next, let's configure the path to the PKCS 11 provider library using the PKCS 11 provider path parameter. This library is included in the Primus PKCS 11 provider folder, so we'll define the path to it. We'll save the file and move on to configure the PKCS 11 pin, which the private ARC will use to connect to the HSM. Open a command prompt with administrator privileges and navigate to the folder containing the CA Vault Manager utility. Use the command secure secret files, secret type as HSM and secret, and enter the PKCS 11 pin, the same one we used earlier to fetch the permanent secret. This command will blind the password into the dbparm.ini file. Establishing a secure connection between the private ARC server and the HSM allows us to now generate and store the private ARC server key inside the HSM. This key will be used to encrypt all later keys generated with the private ARC server. First, make sure the private ARC server is stopped. Then, we'll use the same CA Vault Manager utility to generate a server key on the HSM. For more details, you can enable verbose mode by executing the command setCACryptotrace to 1. Run the command generate key on the HSM/server key to create an AES key with preset attributes, labels, and size. Make sure to note down the HSM #1 parameter, as we'll use it later. After the key is successfully generated, we'll need to change the location of the server key in the private ARC configuration file to point to the new key on the HSM. Return to the dbparm.ini configuration file and mount the recovery private key. In our example, the key is already located on the host machine. To switch from the existing server key to the newly generated key on the HSM, we'll use the change server keys utility, which is in the same path as the CA Vault Manager utility. Let's run the utility change server keys, and we will add the path to the Vault key database location as well as the full path to the Vault emergency password file and the key on the HSM. We'll use the #1 since it's the first generation key created on the HSM. After changing of keys is successful, we'll have to update the server key parameter in the dbparm.ini configuration file. After changing of keys is successful, we'll have to update the server key parameter in the dbparm.ini configuration file. Open the dbparm.ini and change the server key path to the server key name HSM #1, as we used in the previous command. Save the file. Now we can start the private ARC server and check for any errors. Make sure you can log into the Vault using CyberArk authentication and then revert the recovery private key location to the default value within dbparm.ini and save the file. The original server key is now no longer in use, and a key securely stored and generated in the HSM is now in operation. With this change, even if someone were to hack or leak your CyberArk privileged access data, the keys encrypting the data are safely stored inside the HSM, rendering the data unusable without it. For more details and to explore further, check out the links to our documentation and the Securosys website in the video description. Feel free to follow us on our social media, where we regularly post updates and information about the cryptographic world of HSMs. We hope you found it helpful and informative.